A split-phase induction motor is one of the common single-phase AC motors. It has economic benefits and requirements of this power system. Its most of the application are homes, shops, industry, offices, etc. One of the advantages of this type of single-phase motor is its ability to regenerate power automatically on descending grades. The split-phase induction motor basically consists of stator, a rotor, a centrifugal switch which is located inside the motor, two end shields housing the bearings that supports the rotor shaft. In addition to the main winding or running windings, the stator of the split-phase induction motor carries another winding called auxiliary winding or starting winding. A centrifugal switch is connected in series with auxiliary. A split-phase motor has a capacitance in the auxiliary circuit. A phase shift to the main current is achieved by using narrow conductors to achieve high resistance to reactance ratio. Increasing the resistance means that the auxiliary winding can only be used during starting, otherwise it would overheat. A split-phase motor has significant lower torque or starting during to the reduced phase angle between main and auxiliary winding currents. The application of this motor include different loads which are used for general purpose due to excellent starting torque and easily direction reversal characteristic. It finds use in lathe machine, drilling washing machine, woodworking tools, belted fans, drill press, oil burners, centrifugal pumps, compressors, air conditioning fans, floor polisher blowers, dryers, mixer grinder, heating blowers with belt-driven and conveyors with tiny belt-driven and various other low starting torque applications. Capacitor start motors are single-phase induction motors with a capacitor in the auxiliary winding circuit to increase the phase difference between the main and auxiliary winding currents. The word capacitor begins implies that the motor starts with the help of the capacitor. In a motor's distinct start windings, the start capacitor causes a current to voltage lag. The current gradually builds up, giving the armature the opportunity to begin rotating with the current field. A run capacitor boosts the current with the power the motor by using the charge in the dielectric. Capacitor start induction motor working principles. When the capacitor start windings are energized from a one-phase supply, the main winding and the starting winding carry two different currents. There is a 90-degree time phase difference and 90-degree phase difference between the two currents. These two currents produce a rotating magnetic field that starts the motor. The main and auxiliary winding are connected in a parallel during the motor start. A start capacitor stays in a circuit long enough to rapidly bring the motor up to the predetermined speed, which is usually about 70 to 80. Then the auxiliary winding is disconnected from the supply, often by centrifugal switch, and the motor remains powered by a single winding, creating a pulsating magnetic field. In this sense, the auxiliary winding in this design can be regarded as starting winding, since it is only used during the motor startup. Note that the motor will not work properly if the centrifugal switch is broken. If the switch is always open, the start capacitor is not part of the circuit, so the motor does not start. If the switch is always closed, the start capacitor is always in the circuit, so the motor winding will likely burn out. If a motor does not start, the capacitor is far more likely to problem than the switch. Capacitor start induction motor application. These motors are used for the load of higher inertia where frequent start is required. They are used on a wide range of belt drive applications like small conveyors, large blowers, and machine tools. They are used in pumping and compressors. They are also used in the refrigerator and air conditioner compressor, and also used for mini direct drive or geared application. Repulsion motor working and its applications. This motor is a special type of one-phase AC motor working at this can be done by the repulsion of related poles. The stator in the motor supplies one-phase AC supply and the rotor circuit will be shorted using carbon brush. The classification of these motors can be done under single-phase motors. Let us discuss an overview of propulsive motors, which includes its definition, working principles, and its application. What is a repulsive motor? Definition. A repulsive motor can be defined as an electric motor that works by using an AC alternating current. In the past, these motors are used in the transaction motor in electric trains like SR and SR class CP as well as SR class SL. However, they have been outdated by recent types of electric motors. The classification of these motors can be done based on single-phase motors. In these motors, the winding of the stator are directly aligned to the power supply, whereas the rotor is allied to a brush assembly by commutator related to DC, which is direct current motors. Repulsion motor. These motors are equivalent to an AC series motor, including brushes in the motor are not allied with power supply, although they are short-circuited. As a result, the flow of current can be induced within an armature conductors through transformer reaction. The field structure of motor has cylindrical construction. Repulsion motor work principles. The working principles of repulsion motor is repulsion between two magnetic fields. For instance, consider a motor which has two plates along with a magnetic axis. The armature winding of this motor is connected to an armature as well as brushes. The brushes are short circuit with the help of jumper with low resistance. Once an alternating current AC is applied to a stator winding, an EMF will be induced within an armature. The direction of AC will create two poles like south and north, where a north pole can be formed at the top of the magnetic axis and the south pole can be formed at the bottom of the magnetic axis. The induced electromagnetic force direction can be given by Lenz's law, as induced electromagnetic force induces the flow of current within the armature conductors, and the induced current direction will depend on the brush's position. Construction of repulsion motor. The key difference between the AC series motor and the repulsion motor is how the power supply is applied in the direction of the armature. In AC series type motor, the armature gets voltage through the conduction of the power supply, whereas in repulsion motor, the armature can be supplied through induction of the stator windings. Compensated repulsion motor, repulsion start induction motor, repulsion induction motor. They are different in the construction, operating characteristics, and individual applications. These three kinds of repulsion motor are available in the market, which work under the principle of propulsion like flowing. Write the following. Compensated repulsion motor is provided with an additional winding called the compensating winding to improve power factor and provide better speed regulation. This winding is much smaller than the stator winding and usually would one in the inner slot of each main pole and is connected in series with a rotor through an additional set of brushes placed midway between the usual short-circuited brushes. A compensated type of motor finds use where there is a need for high power at the same speed. Repulsion start induction motor. As the same implies, the repulsion start induction motor starts at the repulsion motor and runs as in induction motor. The general construction of this motor is quite similar to the repulsion motor. The only difference is that in addition to the basic repulsion motor in construction, it is equipped with a centrifugal device which operates at about 75 to 80% of the synchronous speed and short-circuit propulsion motor with the operating characteristics of the induction motor. Such motors are suitable for commercial refrigerators, compressors, pumps, hoists, and constant speed drives, particularly those which have high inertia and flooring starting period. The usual rating is from 1/3 kilowatts to 12 kilowatts but for special applications, rating as high as 30 kilowatts are available. Although this kind of repulsion motor price is high, this device is safe where the tears or brushes are run quietly. DC motor components. To understand the working principle of DC motors, let's first look at the components used in its construction. A DC motor usually looks like a cylindrical device with a shaft standing out of it rotates to applying DC. This action is carried out by arranging the following components in the particular manners. A stator. A stator, a steel yoke, a cylindrical metal casing inside which All other elements of DC motors are placed. One face of stator contains a vertical shaft coming out of it, while the other face has two terminals to which the DC power supply is connected. Magnets. There are two stationary permanent magnets installed inside the stator of a DC motor. They act as the north and south poles of the magnet by setting up horizontal magnetic field across them. Armature. In electrical engineering, the term armature refers to the structure of rotating coils under the influence of electromagnetic force. In a DC motor, an armature is composed of a rotor placed between two magnets. A rotor is a structure of laminated disc wrapped around by a conditioning field coil. The shaft pointing out of motor passes along the axis of the armature, rotates along with it. Field coil. The field coil is field winding in a DC motor. It's a coil of copper wires that place the permanent magnet attached to the inside walls of the stator. When DC from the battery is passed through this coil, it forms an electromagnetic whose polarity can be controlled, setting up desired magnetic field. Commutator. A commutator is a hollow cylindrical piece segmented at many spots to reverse the polarity of the electromagnetic armature coil inside a DC motor. It is a critical part of the motor to work on a DC power supply. It sits at the end of the armature around the shaft. The end of the armature coil are connected to the commutator, which all part except brushes, electrical isolated from it brushes. Brushes. The brushes in a DC motor are components that connected to the static terminal to the rotating part of the motor. They are usually made of carbon graphite since it is a great conductor of electricity and have excellent lubricant properties. The commutator is positioned between the two brushes, which are further connected to the motor's terminal, completing the circuit with a DC power source. Working principle of DC motor. A DC motor works on the principle that whoever current carrying conductor is placed inside a magnetic field, it experiences a magnetic force whose direction is given by Fleming left-hand rule. In other words, the DC motor spins due to the interaction of the permanent magnetic field with the magnetic field of the current carrying electromagnetic. Fleming left-hand rule. Fleming left-hand rule is a mnemonic tool to understand the mutual perpendicular relationship between the current and applied magnetic field and induced force in electromagnetic motors. If we extend the index finger, middle finger, and the thumb of the left hand in mutually perpendicular direction, aligning the middle finger with the conventional direction of the current and the index finger with the applied magnetic field, then the thumb gives the direction of the force experienced by conductor. F is equal to BAL net newtons, where B magnetic flux density and I stand for current and L stand for length of the conductor within the magnetic field. When armature winding connected to a DC supply, an electric current sets up in a winding, permanent magnetic or field winding electromagnetism. Provide the magnetic field in the case current carrying mature conductors experience a force due to a magnetic field according to the principle stated above. The shade pole induction motor produces a very small starting torque, about 50% of full load torque. The efficiency of the shade pole motor is low because of the continuous power loss in the shading coil. It is suitable for small devices which require low starting torque. The direction of the rotation of the shade pole motor depends upon the position of the shading coil, which half of the pole is wrapped with the shading coil. Therefore, the direction of the rotation cannot be reversed unless the machine is constructed in a way the shading coil can be shafted to the another half of the pole. For rotating, the shade pole motor has poor starting torque. The power losses are very high and the starting power factors is very low. Hence, the motor gives us low efficiency for a higher power rating design. That's why the motor is designed with the low power rating, typically 1 to 20 HP. 1 over 20 HP. Design is type small and motor has low power rating. Types of the most common type of shade pole motors fractional horsepower used in the squirrel cage induction motor. This is a rotor that consists of laminated steel cylindrical with conductive copper of aluminum bars embedded lengthwise in its surface connected at the end. Polyphase AC motors require no such tricky to spin in a definite direction because their supply voltage waveforms already have a definite rotation sequence. So, do the respective magnetic field generated by motors, stationary windings. In fact, the combination of all three phase winding set working together creates what is often called a rotating magnetic field. It was this concept of a rotating magnetic field that inspired Nikola Tesla to design the world's first polyphase electrical system, simply to make simpler, more efficient motors. The lead current and the safety advantages of polyphase power over single-phase power were discovered later. Linear string lights analogy, what can be confusing concept, is made much clearer to analogy. Have you ever seen a row of blinking light bulbs such as kind used in Christmas decoration? Some strings appear to move in a different direction as the bulbs alternately glow and dark sequence. Only string just blink and of no apparent motions. What is generator? A generator operates with a reverse path of power, transforming mechanical energy into electrical one. Before learning about the differences between motor and generator, it is vital to know the details of current voltage through truly electric generators. Converting mechanical energy into electrical energy according to the Faraday's law, whenever there is a modification in the magnetic field within a conductor like wire coil, electronics can move perpendicularly to that magnetic environment. This produces an electromotive force, which generates a flow of electrons in one direction. This phenomenon can be employed to generate electricity in the generator. The output, the magnet and the conductor are moved relatively in another to produce this magnetic flux. The wires are connected to the light coils, raising the number of wires and output electromotive force, continuously circulating either the magnetic or the coil while keeping the other in the place gives the constant flux vibration. The moving part is referred to as a rotor, while the stationary section is called the stator. Electric generators fall into two wheels type: the dynamos, which produce direct current, and alternators, which create alternating current. The dynamo was the first type of generator that was applicable for industrial usage. It was intended independently by several poles. During the Industrial Revolution, the electric dynamo utilizes the circulating coils of wire and the magnetic field to transform mechanical energy into DC by several people during the Industrial Revolution. The electrical dynamo utilizes the circulating coils of the wire magnetic field to transform mechanical energy into DC. Dynamos were utilized by energy generating, usually steam, as a source of to create needed mechanical energy. Today, electric dynamo has few applications outside of a few low energy use. Alternators are far more common for the generation of electricity. This form of generator transforms mechanical energy into AC source. A rotating magnet introduced as rotor within a set of conductor coil, or iron core introduced as the stator. As a magnetic field produces, it creates an AC voltage in the stator. The magnetic field can be produced either by a field coil electromagnetic or by permanent magnets, an automobile alternator, as well as the main power source that supports electricity for grid are electric generators.